Not all tornadoes come from supercells. In this video, we're going to look at non-supercell tornadoes. Perhaps one of the most commonly known non-supercell tornado is called a gustnado. Basically, what happens is you have a hot, dry day and you get a wind gust. That wind gust picks up a little bit of dirt, causes a little bit of circulation, decreases the pressure, creates a good circulation pattern, picks up a lot of dust and debris. But there are no clouds and no rain involved. It's basically a tornado without a cloud. And it's also going to be a lot weaker than a regular tornado. And that's what we'll see with all of these non-supercell tornadoes. They all tend to be weaker than the supercell tornadoes. Here's another common non-supercell tornado. You've got a regular cumulus cloud, which means you've got a nice strong updraft. And you've got winds passing by in the area. You get a little bit of wind shear, you create some spin. The spin and the updraft are in different places. But as the cloud starts to move along, the updraft may merge with the spin, creating ourselves a little tornado. Basically, you get the same conditions you have for a supercell tornado, rising air, spinning motion, but without the super strong supercell tornado. These are often called land spouts or cold air funnels. And this is often what they would look like. You just see you've got yourself a small tornado. You get a lot of debris and stuff picked up, and it gets kind of faint here, and then it gets really strong. What's happening, the low pressure is causing the saturation vapor pressure to decrease, thus the relative humidity increases, allows clouds to form lower and lower. They get to about this point. Then down below here, you don't have any clouds at all, just debris that's picked up by the land spout. You get these over the water as well. When they do go over water, then you start seeing these very large white columns because it's water. You're just picking up a whole lot of water. You're creating a cloud, more or less, not from cloud droplets, but from ocean droplets. But a water spout is formed the same way that a land spout is. So how do we observe tornadoes and how do we predict the severe weather? Well, Doppler radar is by far our best instrument for the day. Our Doppler radar tells us everything about tornadoes that we can get right now. If you get a tornado warning, you can bet they saw it on a Doppler radar. We are starting to enhance that technology, however, and we're starting to for example, use 2 Doppler radars and combine that information together to give us 3D views of tornadoes. A lot of storm chasers will chase down these tornadoes, and you'll have 2 trucks with radars on them. One parks in one place, one in another place, and they're taking Doppler radars images. And those radar images will be synchronized later on in a lab where they can get a good 3D view of the tornado. Pretty cool stuff. Radars are detecting tornado vortex signatures. We're starting to develop something called Doppler LiDAR. Radar is a sensing technology using radio waves, specifically microwaves. LiDAR is a very similar technology, but we use physical light instead of microwaves. And over the last couple of decades, we've been improving all of our radar systems, giving them much better computing power and ability to collect a whole lot more data and to process the data a lot faster. It's called NexRad, or the Next Generation Radar System. So NexRad has been one of the best improvements we've seen in tornado and thunderstorm observations in quite a while. And they're still working on that. It's a continual improvement and will always be an improvement, really, to improve our radar system.